Good morning, everyone. My name is Girish Bhatia, and I study in Acropolis Institute of Technology and Research. Today, I am going to give a PPT presentation on topic disk scheduling algorithm, which comes under scan algorithm, which comes under operating system. So, let us start. So, first of all, what is disk scheduling? This scheduling is done by operating system to schedule input-output requests arriving for the disk. Disk scheduling is also known as input-output scheduling. So now there are various kinds of scheduling algorithm. So that are first come first serve algorithm, shortest seek time first algorithm, scan disk algorithm, C-scan circular scan algorithm, look algorithm, and C-look, that is circular look algorithm. So now let us start the introduction of scan algorithm. So the scan algorithm is a disk scheduling algorithm used by operating systems to determine the order in which read and write operations or requests are serviced by a disk. It works by moving the disk arm in one direction till end. Example, from the outermost track towards the innermost track, servicing requests along the way, and then reversing direction to serve the remaining requests. So scan algorithm दूसरे disk scheduling algorithm जैसे FCFS first come first serve and shortest seek time first जैसा ही है, लेकिन अभी अपन देखेंगे कि वो स्कैन एल्गोरिथम कैसे दूसरे एल्गोरिथम से अलग है. So now the overview of disk algorithm, scan algorithm. So scan stands for elevator algorithm as it mimics the movement of an elevator. So scan algorithm को elevator algorithm भी बोलते हैं. अब now the disk arm starts from one end and moves towards the other end, servicing all the requests along the way. And then when it reaches the end, it changes direction and moved back, servicing or serving any pending request on the way. So ये दूसरे एल्गोरिथम से ऐसे ही अलग है कि जहाँ पे डिस्क आर्म यानी मतलब हेडर if it starts to move from in one direction like left or right, if it suppose it starts to moves in left direction, then it moves towards the end of the left direction and then it changes the direction. But after it, if it moves in the right direction, it does not move to till the end of the right direction. So in this way, it is different from the other disk scheduling algorithms. So now scan algorithm steps. तो जो मैंने ही बताया वही अभी एल्गोरिथम की स्टेप्स में लिखा हुआ है, अपन एक बार पढ़ लेते हैं. So it starts by determining the direction in which the disk arm is moving, example inward or outward. Sort the pending request based on the position on the disk. If the disk arm is moving outward, serve request in ascending order. If the disk arm reaches the end of the disk, then change the direction. If the disk arm is moving inward, serve request in descending order. Continue serving requests until all pending requests have been processed. So अपन अब एक एग्जांपल लेके इसको बहुत इजीली समझने की कोशिश करते हैं. So now we will understand about scan algorithm using by a numerical. So first of all, input, and in input we have request sequence, which is a static request sequence, that is 176, 79, 34, 60, 92, 11, 41 and 114. And the initial head position is 50. And we have also given that the direction in which the head point position or the disk arm is to be moved first is left. That is, we are moving from right to left. So now let us start to solve the numerical. So the following chart shows the sequence in which request tracks are serviced using scan algorithm. So if we start our, if we see that our header position is at 50, and if we choose to move in the left direction, though we can also move in right direction, but we suppose we choose to move in the left direction, and then the head pointer moves in left direction to 41, 34, 11, and then at 11 we do not have request 0, but then also it moves till 0. Means if it starts to move first in the left direction, then it will move till the end of left direction. And suppose if we started to move the head position in right direction, then it would move to the end of right direction. But here till the in the left, it moves in the left direction, so it moves to the end of left direction, that is till 0. And after that it changes its direction, so then it starts to move in the right direction. So in the right direction the track comes at 60, and then it moves to 79, then 92, then 114, and then till 176. And at 176 it stops, it does not move to 199. So in this way our problem is solved. So now the total seek count is calculated in this way. So like 50, if we do like 50 minus 41 plus 41 minus 34 till, if we minus all the adjacent disk, or we can directly do it by, in the left direction it was moving from, header was at 50 and then it was moving till 0, so 50 minus 0, and then it changes its direction and then it moves to 176. So 17 from 0 to 176, so 176 minus 0, and if we add it we directly get easily 226 is our total seek count. So now the advantages of scan algorithm are as follows. It is efficient for systems with high disk traffics, avoids the problem of starvation as it serves all requests eventually. Requests closer to the current position are served faster than requests to the opposite end. So इसके advantages यही हैं कि ये जहाँ ज़्यादा डिस्क हैं या ज़्यादा ट्रैफिक है तो वहाँ ये इजीली हो जाता, इजीली बहुत इजी मेथड है उसको सॉल्व करने का। एंड ये सारी रिक्वेस्ट को सारी डिस्क को ट्रैक करता है, कोई भी डिस्क इसमें छूटती नहीं है। एंड जो करंट पोजीशन या हेड पोजीशन के जो पास की डिस्क है वो इसमें पहले सर्विस हो जाती है, रैदर जो डिस्क जो इससे दूर है। So now disadvantages of scanner algorithm are as follows. It is poor response time for requests located far away from the current position of the disk arm. Inefficient for systems with low disk traffic or evenly distributed requests may lead to the increased disk head movement. So it has poor response time for requests that is located far away. So the requests that are located at the end or at the opposite ends, it takes very much time to track them or service them. So it is the main disadvantage of scan algorithm. So now the conclusion is the scan disk algorithm. Scheduling algorithm is widely used in operating systems for efficient disk input-output operations. It optimizes the disk arm movement by servicing requests in manner similar to an elevator. While it has advantages in certain scenarios, it may not be the best choice for all disk scheduling situations. So in input-output operations, it has a very efficient method to solve that input-output operations in a disk, and it serves the request like an elevator. So that's why it is also called as elevator algorithm, and it has advantages in many scenarios or certain scenarios, but it is not always the best choice for all disk scheduling algorithms. So at the end, I would like to say thank you very much.